I'll share the link of the drive in that sheet only, in which video lectures link is shared.
Okay, ma'am. Thank you, ma'am.
Okay. So I'll go through week 0 assignment last year basically. Suppose you roll a 6-sided die twice. What is probability that you get composite number? Oh, wait a second. This is this assignment only. Wait a second. Sorry. Suppose you roll a 6-sided die twice. What is the probability that you get? Actually, there is a little difference between only the last year assignments. Some questions are totally changed. Some are similar. Some are same as well in both the rules. So I'll give you some time. Try to solve it. It's fine if you can't. We'll solve together.
Ma'am, the answer is 1/4.
Yes, absolutely correct. How?
Ma'am, 2, 3, and 5 are the prime numbers, and that is 3 out of 6.
So,
Two,
hmm
two dice roll twice. 1/2 into 1/2, 1/4.
absolutely correct. Next question. We are starting from assignment 0, so that is easy to harder level we'll go. Suppose you roll a die n times. What is probability that you get prime number in all n rolls? Options are, though it's similar only.
Option B, ma'am.
Option B, how?
Same example as above, ma'am. 1/2 times the to the power of how many times the die is rolled.
So basically 1/2 power n, basically because they were twice, so that is why we were multiplying by 2, 1/2 multiplied by 1/2. So now it's n times, so that is why we have this. I think the other next question is the same only. Do I'll write it. So in the course, you will study. Okay. In this course, you will study the following case study. Let's make a deal. There was a TV show. I'll not write a whole question. Whose host was Monty Hall. 3 closed door. Maybe this is the same only. You can open your assignment 0 and you can check the question 3. Though we have solved in the class as well. Maybe I'll move to the next question itself because it's already solved. Now, the next question is the instructor designs a single answer MCQ question with total 4 options. Suppose option number 1 is correct. The instructor submits this question to NPTEL staff. So now, who shuffle? Okay. He shuffles all the options randomly before adding it to exam. Probability that option 1 is still correct. Now what they are saying is, suppose option 1 was correct earlier. Now they shuffle it, and now what is the probability that option 1 is still correct after I'll say shuffling? The options are 1 by 2, 1 by 4, 3 by 4, and 1 by 24.
Ma'am, is it 1 by 4, ma'am?
Yes, yes. It's easy only, like option number 1 is still correct, obviously. Can you give me the explanation first?
Ma'am, there are four options, and option one should be correct. So there is three factorial ways in which one can be correct. One can be placed other
Hmm.
than correct. Total number is 4 factorial. So 3 factorial over 4 factorial, I am getting 1 by 4.
Yes, absolutely correct. Now suppose Merlin selects two real numbers and put them in two envelopes. Using a fair coin toss, he selects one of the envelopes and reveals number in that envelope. He asks you whether number in other envelope is bigger than one revealed. Can you guess correctly with probability greater than 1 by 2? Options, I'll read again. Yes, I think I have also missed. I also have to read the question carefully. Maybe, no idea. Merlin selects two real. Yes. Can someone read the question and explain first?
Merlin selects two real numbers and put them into envelope. Using a fair coin toss, he selects one of the envelope, and to reveal the real number he has put inside the envelope, and we have to choose. He asks whether we chose the envelope, and in that envelope the number is greater than the number in another envelope, and we are asked whether the probability we can guess correctly with the probability greater than half.
Hmm. What should be the answer?
No, ma'am.
It's basically no idea. Basically, no only we can't guess basically correctly. That is what. So next question.
Ma'am, is B the
One
answer or
one
D the
thing.
answer, ma'am?
One more thing. One more thing. Wait a second. Merlin selects two real number and put them in two envelope. Okay, I'll read it once again. Using a fair coin toss, he selects one of the envelope and reveals no in the envelope, in that envelope, and reveals the number in the envelope. Sorry, reveals the number in the envelope. So okay, fair coin toss. He's revealing the number in the envelope. He asks whether the number in the other envelope is bigger than one you revealed. Can you guess correctly with the probability greater than 1 by 2? It's written no idea. The D is the right answer. Is it like you can't guess correctly? You don't have idea whether it is greater than 1 by 2 or it can be less than 1 by 2? Is it like that? Should we
No, ma'am.
proceed? Like how? The number can be greater than 1 by 2 or less than 1 by 2?
Yes, ma'am. Depends on the event which is actually occurring.
So can I say no idea because it's actually no idea, but I'd like to know, that is the main thing. So basically, we can't guess here. That is what is the answer. These questions may mostly are diplomatic, like whether to write no or how many people do you need? Okay, this is also the question. Similar question, which was in the assignment. So that I think it will take time, and it's a good question. The probability of at least two of them sharing same birthday is greater than half. I'll just ask how to solve. Any idea, or I should try? Okay, someone has written 23. Can you tell me how 23 Shobik? Though we have solved this question in the class, I think you were also there. So basically, it's like maybe I've solved through some other way. Today I was going through this. Basically, two people are having the same birthday in the room. What we have to say, that how many people do you need in the room so that the probability of at least two of them having the same birthday is greater than 1 by 2. So I have to choose the two of them. Basically, if I say NC2, that is basically n factorial over 2 factorial n minus 2 factorial, which is nothing but n into n minus 1 by 2. Can I write this? Now, which distribution do you think will be applied here? Binomial, Bernoulli, geometric, exponential, Poisson. What do you think? Can someone explain the type of distributions, and can someone explain why like a particular distribution cannot be applied in this question, why a particular distribution can be applied in this question? Yes, come on. Okay, can someone tell me what is Bernoulli? What is Bernoulli distribution? Right is nine.
Repeating the
Ma'am,
same event will till we get the probability.
Okay.
like
Yes,
we
some
continue to perform the event until we get the success. So that's for that the probability is calculated using Bernoulli distribution.
okay. Is it like continue to get until we get the success? Then what is geometric? Yes. Basically, Bernoulli is like either success or failure, like coin tossing. Geometric is until you get the success, basically fail, fail, fail. When you'll get the, what is the probability of getting the success, basically after consecutive failures? That is basically geometric. What is binomial? Yes. Come on, anyone? What is binomial distribution? Yes, today is the last class. Come on. Can I say some of these Bernoulli only? That is binomial. And if I say that
Yes, ma'am.
how many people do you need in the room so that the probability basically having the same birthday, either these two of them will have the same birthday or either two of them will not have the same birthday. That is what is there. But what is Poisson? As I gave you the example, when the number of events, it's similar to binomial only. But when n is very large and p is small, very small, then we say Poisson distribution. Like probability is very small. Like suppose I have a book, I have to say like there are minor misspelled very minimal misspelled words or letters. So how many are there basically? So basically they are very less. N is very large. I have to go to each and every word and check whether it's misspelled or not. But the probability of getting misspelled is very small. That is what they are saying. So we are here using suppose the Poisson distribution here. And what is the formula? Basically, it's like lambda raised to power k e raised to minus lambda over k factorial. This is basically the formula. And if I say that basically none of them is having the birthday on the same day, I can say x is equal to 0, which means e raised to minus lambda, e raised to minus lambda only I'll write. And now what I want to say, at least one of them is having the birthday on the same day. Wait a second. Wait a second. Wait a second. Am I audible?
Yes, ma'am.
Sorry for the inconvenience today. So I can say that more than one birthdays if I same, then I can say 1 minus e raised to minus lambda in that case. And now, okay, where were we? So we were saying that, okay, two are selected and how many of them will have the birthday, not have this birthday on the same day. I can say again, the expected number of success. What is basically lambda here? That is expected number of success. Suppose I'm considering 365 days only. So 1 by 365 if they're having the same birthday. So which means that one day among the 365 days. So 1 minus e raised to power n into n plus 1 by 2 into 365. And the probability here, it should be greater than basically 0.5. And we have to substitute the different values of n and check when the probability is greater than 0.5. So basically we'll get it as 23 here, though it's basically tough to find out by substituting those values and all. Or you can substitute the value of 0.5 and check the value of n. Is it clear or is there any doubt? Because last time also many of the students were saying that it's a lengthy problem and all. Though there was a related problem like this. Is it clear? So what we have done is, how many people in the room, they're having the same birthday. So we said, okay, let's take the pairs of the birthdays. Then we'll say that, okay, we'll apply the Poisson distribution. And we said, okay, if no birthdays are same, then e raised to minus lambda. If more than one are having the same birthday, then this. And how we'll have the lambda, basically the number of success, basically the same birthdays of the two of them. And probability is greater than 0.5, and we'll calculate the value of n, which is equal to 2.
Ma'am, ma'am, how do you get n into n plus 1 by 2 into 365, ma'am?
Okay, you got this. Okay, n into n minus 1 by 2, sorry. You get this, how I got this n into n minus 1 by 2? I have to choose two people among the n of them. So basically I'll choose two among n of them, and what is the probability of having the same birthdays among 365 days? Basically one, it's like one among the 365 days. Basically one day they'll have the same one one date among those 365 days, they'll have that. So what is the probability of that? That is 1 by 365. Am I correct?
Yes, ma'am.
So that is how we proceeded. Should I proceed next? So the next question in the assignment is, okay, these are all the repeated questions. I'll try not to solve the repeated because we have already solved the new questions. I'll take up. Okay, this is now assignment 1, last year. Basically, I think it's 2021 questions. If 8 coins fall to floor, what is probability that there are 4 heads and 4 tails? Okay, can someone tell me the answer? It's easy only, I think. Yes. So how to solve which distribution? Yes, come on. Come on.
Ma'am, is it 35 by 128, ma'am?
Yes, absolutely. So which solved?
Ma'am, I just multiplied and got it, ma'am.
Okay. Can we apply the binomial distribution? Can I say that 8 coins fall into floor? What is the probability? 4 heads. So basically, it's like I told you, like Bernoulli is basically head or tail. Binomial is I'm repeating the Bernoulli experiment again and again. So basically, I'm repeating it 8 times basically. So that is what. So there are 4 head and 4 tails. So 4 head basically. So 4 times I'll get the head. Suppose I'm taking that head is a success about 8 time from the 8 like NCR p raised to power r q raised to power n minus r. Basically, this is the success 4 times head if I'll get suppose. So how what is the probability of getting the head? That is half only because we are saying that it is a fair coin, and q basically 1 minus half is also half only, and 8 minus 4 is again 4. So we'll here get 35 by 128. Next question. Number is perfect if it is equal to sum of all its proper divisors. We roll two standard six-sided dice. What is probability that product of numbers that appear on two faces is perfect number? Can someone tell me what is perfect number, and can someone read this question? And okay, I'll write the options as well. What is the perfect number in the die, six-sided die? Can someone give me the examples of the perfect number as well?
Ma'am, a number is perfect if some of its divisors add up to that number.
Okay, so can you tell me, among six-sided dice, which is the perfect number?
Only 6.
Only 6. How? Can I say 2 plus 3 plus 1 is 6? Its divisors as the sum of the divisor are equal to 6. What about 28? Though I'm not talking about dice now. What about 28 though? Is 28 a perfect number?
Yes, it is.
How? Can I say 1 plus 2 plus 4 plus 7 plus 14? It's equal to 28. Its divisors. That's why. Okay.
Yes.
Now we know what is a perfect number. So what is it? Now they are saying is what is the probability that the product of the numbers that appear on two faces is perfect number?
Ma'am, is it 1 by 12, ma'am?
No. Mm,
Ma'am, 5 by 36, ma'am.
No,
Option 1.
no, no, no. What are the possible outcomes?
4-2, 2-4, 5-1, 1-5, and 3-3.
Uh, Once, okay. Can you repeat again?
Okay, 1-5.
Is it not 1-6?
Ma'am,
Okay.
7 is not a perfect number.
Yes, yes, yes. 1-5. Hmm.
And it's reverse 5-1,
Hmm.
4-2,
Hmm.
2-4,
Hmm.
and 3-3.
Actually, the answer given here is let me check. That is 1/9. But
Ma'am,
then
5 out of 36, ma'am.
that is what. Maybe it's written incorrectly. 5 out of 36 only. That is what I am also perceiving. Mm, Let me check. Hmm. Can you read the question again? Numbers, the product of the numbers. What is the probability that the product of the numbers that appeared on two is the perfect number? Is the product is the perfect number? You are saying about the sum. This is not. Maybe you are checking the previous assignment question. This is like this assignment question. Now they are saying product of the numbers. Basically, it's like 1 and 6. Are you getting my point? I was also
Okay.
confused.
Yes, ma'am.
Now, can you tell me?
1,
4
6,
by 36, ma'am.
and 6-1, and 2 and 3, and 3 and 2.
Now, is it correct? 1/9. Should we proceed? Read the question very carefully in the exam. Don't think that you have already done the question. Can someone read the question and explain and just explain the question and then move to answer, like how we'll solve? First, explain the question. Only read the question.
Pack of 52 cards has been dealt to 4 players. What is the probability that one of the players receive all 13 spades?
Hmm. Yes. Basically, can I say that 52? How many cards are we are having? That is 52. Now, what we are saying that 13 spades, basically how 13 each player will get 13 cards, basically that is 52c 13 they'll get. And now, which means that total is 52c 13. Now, can you tell me, try at least, then only I'll first let you you should try, then I'll tell. Yes, come on.
Option C, ma'am.
Option C. How?
Ma'am, 52 and 13 combination, ma'am. When 13 cards are given to a player, 13
Hmm.
out of 52, next card will be 12 out of 51, and so on, ma'am. And only one time it can occur because we are already giving all the 13 cards. So 52 C13, 13 by 52, and so on factorial, ma'am. But we invert it, we get 52 C13, 1 by 52 C13.
What about others? What others think about this? Yes, come on. Come on. Is he correct or not? Guess at least. Why all others are not participating? Yes.
Ma'am, which week assignment is this?
Actually, this is last year assignment. Assignment number 1 of last week.
Okay, ma'am.
Can you guess, Preshan? Is he correct or not?
Ma'am, please show
Yes.
the queen.
Yes.
I think he is partially correct
Okay. How partially?
because he's talking about only one players, but it can happen to all the four players. So there is
Yes.
a possibility of or so that's adding and adding it gives to four.
Yes. So basically, we are distributing among 4 players. It can happen to all the 4 players. So the answer is basically D. So partially correct because 52C13, that was correct. But we have now the 4 players basically. So that is why 4 by 52C13. Next question. A deck of cards is shuffled and cards are drawn one at a time until queen appears. If we draw another card, what is more likely? That next card is Queen of Clubs or King of Hearts. Similar question I think we have done. So options are, in this question also, many were having the doubts. It's easy only, but somewhat tricky. Can someone read and try to give the answer?
Ma'am, both are equally likely.
Both are equally likely. How? Can you first read the question and then explain?
A deck of cards is shuffled and cards are drawn one at a time until queen appears. If we draw another card, what is more likely that next card is queen of clubs or king of hearts?
Yes. So if the queen is picked, then also how you're saying that both are equally likely? We discussed, I think you were
Ma'am,
only. Yes.
yes, ma'am. Ma'am, there is only one card of queens of club and one card of queen of hearts. And ma'am, if we choose randomly from 52 cards,
Mhm.
then both are equally likely. Ma'am, both have 1 by 52, 52 have probability of 1 by 52. That's why they are both equally likely.
And this is just for the confusion that like one at a time until queen appears. Like basically, this is just for the confusion. Both queen of club and king of heart, as you say, that they are one in number. So basically, it doesn't matter whichever, like they are one in number. They are both 1 by 52. So both of them are equally likely. Next question. Again, I think this is a repeated one. I suppose 3 people get their hats returned in random order. What is probability that at least one of them gets the correct hat? Yes.
One by three, ma'am.
What about that? How many ways, yes, you answered. How many ways are there to distribute the hat among 3 people? Can I say 3
Ma'am,
factorial?
6.
6
6
ways.
ways.
Yes. That is basically 6 ways. And now, what is the probability? At least one of them correct. So, what is the probability that none of them is correct? Can I say it is that like 1, 2, 3 I'm having? 1 hat is given to 2, 2 hat is given to 3, and 3 hat is given to 1. What can be the other combination? Incorrect, incorrect. Basically, 1 is not given to 1, 2 is not given to 2, and 3 is not given to 3. What can be the other incorrect? Is it possible? Are you getting my point, like what I'm trying to say? Can I say 1 is given, oh sorry. 1 is given to 3, 3 is given to 2, 2 is given to 1? Incorrect. I think these are only the possible ways. So basically, 2 incorrect ways. And if the question is at least one of them is correct, so can I say 1 minus probability? None correct, which is equal to
Yes,
1 minus
ma'am.
by 6. That is equal to
2 by
2 by 3.
2 by 3. Two by 6, 2 by 3. And you answered 2 by 3 only or 1 by 3?
1 by 3, ma'am.
Okay, okay. So basically it's 2 by 3. You got the way how basically?
Yes, ma'am.
Now the next assignment number 2. Someone was telling me we haven't solved assignment 2 of this year as well. So we'll solve side by side, like one, because they are almost same, like some difference. Basically first question of this and then first question of that. First previous year question, then we'll solve. Okay. The other. Which of following is valid. I'll not write this year question. This is previous year. You can open meanwhile assignment 2 of this year as well. I think that you are having the access. Can you tell me which of the following is the valid sigma algebra? There can be multiple options also, like 1, 1 and 2, 1 and 2 and 3, all of them.
Only 1 and 2.
Why?
Because for 3, the complement of A union B is not there.
Absolutely correct. Now, can you open the assignment 2 of this year as well so that we can solve the similar question here also? Can someone read the question? And tell me the answer.
Set A as the elements A, B, C, and D. Which one of the following is valid sigma algebra on A?
Yes. What is the answer?
Both option 1 and 2 is using the same logic option.
Yes, yes. I think we have, I don't know, feeling like we have solved. Okay, it's fine. Next question. Pick two real number, A, B. Uniformly at random. From infinite sample space. Minus 1, 1. What is probability that A square plus B square is greater than 1?
Ma'am,
Yes.
ma'am, can you solve the current year assignment to first question, ma'am?
Okay.
Please explain, ma'am.
Assignment, basically, can someone tell me what is sigma algebra? Can someone explain? I'll explain again. Can
Okay.
someone explain her? Again, the first question. One of your friend is having the doubt. Yes.
Ma'am?
Yes.
Ma'am, sigma algebra is a set of sets, ma'am, which contains ma'am set and its complement both.
So basically, we should have the set itself, the whole set, and its complement. So we are not having the complements of some of which complement we are not having in the third option. Can you tell? Can I say C is present but ABD is not present? C is complement. So that is why it is not a sigma algebra.
Yes.
If AB is in the second question, in the second option, if AB is present, then AB's complement is also present, that is CD, and whole set is present ABCD, and the null set is also present, that is also fine. And in the first option, ABCD is present and its complement, that phi is also present. Basically, whole set and phi is also present. So if a element, the set is present, can I say its complement should be present there? But in third option, it's not present. That is why basically we are saying that both 1 and 2 option are the valid sigma algebra and third option is not a valid sigma algebra. Is it clear?
Okay, ma'am.
Yes, we were trying to solve this. Can someone try it? similar question was in the is in the this year as well, but it's somewhat different. Yes.
1 minus pi by 4.
1 minus pi by 4. Can you tell me? Yes, absolutely correct. Nice, actually.
Ma'am, because like if like A and B can be selected from the range -1 to 1, and we think it as of geometrically, it will be a square shape formed with the vertices like 1 1 -1 -1 and 1 -1 and -1 1. So it will be like the square somewhat formed, and a square plus b square is equal is greater than 1. So if we assume a square plus b square is equals to 1, that is clearly a circle. So it implies the region that is outside the circle but inside the square.
Yes. So basically, absolutely correct. So basically, outside the, can I say that area of the square minus area of the circle? As you said that it is outside the circle but inside the square, that is what is the area we have to consider. Can I say this? Over
Yes,
total
ma'am.
area of
Yes,
square. So 4, which is 2 into 2, basically the distance between them, minus what is the area of circle? Pi r square,
1 pi.
pi and over 4. That is 1 minus pi by 4. Next question, which is okay. If A and B are mutually exclusive, then they are also independent. If A and B, and the similar question I'm not solving. The second question, same in this assignment also is there. Okay, let's see this. If A and B are independent, then they can be mutually exclusive. First of all, can someone tell me what is mutually exclusive event and what are independent event? What is the difference between both of them? Then we'll go to the question like which one of them is correct, both of them are correct or both of them are incorrect. First, can you tell me like what are mutually exclusive and what are independent events?
Mutually exclusive are the events one, like if one is happening, the other will not happen. And independent events are the events which are not dependent on each other.
Yes, if I say that, okay, which means at the same time, both the events shouldn't happen. That is basically mutually exclusive. And independent means one event will not affect the other. That is independent event. Now, can you
Yes,
tell me if one of them is correct?
like the first one is the false, like if they are mutually exclusive, then they are clearly dependent.
That is false. Okay. What about second?
Uh, if they are independent, yes, they can. I think they can be mutually exclusive.
What about others? He's saying that first option is correct. What about others? What others think about this? First is correct, second is correct, both are incorrect.
Both are incorrect. No?
Yes, absolutely. Both are incorrect. Now, how can you say that both are?
Ma'am, if they're independent, they are not related, ma'am. But it is given mutually exclusive for it should be exclusive means it should be dependent, ma'am. So it's given independent. So
Can I say if which one of them, okay, whatever I have written, which one of them is independent and which one of them is mutually exclusive?
First
first
one
is
is independent
independent,
and second one
second is
is mutually exclusive.
So basically both are incorrect, and first one is basically both of them cannot be like possible. If they are, we can't say that if they're independent, they can be mutually exclusive. Okay, next question. Okay, let's read the assignment 2 question now. Can someone read that? Third question, assignment 2 of this year.
which of the following is true for two events A and B each having non-zero probability of occurrence? The first statement is if A and B are mutually exclusive, then they are also dependent. Second is if A and B are independent, then probability of A union B is smaller than probability of A plus probability of B.
So which of them is true?
Both are correct.
Both are correct. Okay, first one we saw now only, then they are independent. How second one?
Probability of A and B is
So basically, if they are independent, it's probability of A. We are assuming that both are greater than 0. So basically, that's why if we'll leave this out, then can I say this? Because if they're independent, then this is equal to probability of A, probability of B. If minus sign is gone from here, then obviously this is greater.
yes, ma'am.
Absolutely correct. Now, moving to the fourth question of the previous assignment. Suppose, I think we have done this in class also. Okay, let's see. COVID-19 RT-PCR test is 95% accurate. It's not an assignment 2 of this year, but maybe some other assignment because I have solved this question. Also assume we have solved now this COVID-19.
Yes, ma'am, I think so.
Point 2, that is 20%. I'll expect all of you to solve this. Yes, please, someone can read the question and explain. Okay, I'll read it and I'll give you some time to solve it. Suppose COVID-19 RT-PCR test is 95% accurate. Now, also assume prevalence of COVID is 20% of the population is COVID-19 infected. Basically, 20% of the population is COVID infected and RT-PCR test is 95% accurate. Basically, 20% are positive. If your RT-PCR test comes out positive, what is the probability that you are infected? We have solved a similar question, I think so. I'll expect from you that to solve this question. Okay, I'll just come in 10 minutes. Meanwhile, I'll expect you to solve this question, the fourth question, as well as assignment 2, fourth question. And we'll discuss.
Ma'am, please solve assignment 2, second question, ma'am, for current year.
Okay, okay, okay.
Okay,
I'll
ma'am. Okay.
I'll come just in 10 minutes.
Okay,
Meanwhile,
ma'am.
uh, I'll uh, I'll tell everyone, please solve the second question as well, the fourth question as well of the assignment 2, and this question which I
Okay,
have.
sure, sure, ma'am.
Okay, I'll
அசைன்மெண்ட் டிஸ்கஸ் பண்ணிட்டா தெரியும் யார் என்ன பண்ணிருக்காங்க வேற வேற படிக்க போயிருக்கேன் உனக்கு ஏன் வெளியே வா உள்ள வானே இந்த போட
Am I audible? Hello. Okay, let's meet at 6:20. Then maybe everyone is, I'm hoping so that everyone is busy in solving the question. $620, I think. So, any one of you have solved this question? Yes, come on. What is the answer? Or at least you have tried. How? Yes, yes, come on.
19/23.
Okay.
Yes, 19/23. I'm also getting that.
Okay, yes, absolutely correct. So let's solve it so that whosoever are having the doubts, their doubt will also get clear. So as you have solved it, can you help me in solving this? So can I say base theorem you have applied or any other method like
Base theorem only.
base theorem only? So what is the probability if your RT-PCR test comes out to be positive, then what is the probability that you are infected? That is basically given that you are positive, we have to find that basically that we are infected. Then base theorem if I'll apply, that is basically if infected, given infected, then what is the probability of getting positive multiplied by what is the probability of getting infected divided by the probability of positive. So what is this? Given infected, then positive, what is the probability?
0.95.
0.95. What is the probability of getting infected?
0.2.
0.2. What is the probability of being positive? How you have solved this?
0.95 into 0.2 plus
Hmm.
0.05.
0.95 into 0.2
0.2
plus 0.0
plus
into
into
0.8.
0.8.
So basically, can I say that probability of being positive, we have written like probability of positive infected, given infected, multiply by probability of being infected plus probability of being positive, not infected, multiplied by probability of not infected. Basically, what we have done conditional probability only. Can I say that this is conditional only? Or I can say marginal basically by saying that probability of positive in both of the cases we have added up. That is what we have done. And what is the answer? It's basically 19/23. Now, what about the fourth question of assignment 2? Can someone read it? Fourth question of assignment 2, yes. This one, basically fourth question of assignment 2 this year. Can you read it? Come on. Yes. Am I audible? Why no one is responding? I'm just asking to read the question only. I think break has gone, like people have not come from the break itself. Okay, I'll read myself. A person uses his car 30% of time. Anyone is here or all are sleeping? Yes. Am I audible? Maybe.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am, audible.
Okay. So basically, a person uses his car 30% of time. So what they're saying is, car is used 30% of time, walks 30% of time, rides the bus 40% of time as he goes work. He is late 10% of time when he walks, 3% of time when he drives, and 7% of time when he takes the bus. So this is a late probability. Given that he was late to work. So what we are saying that he was late to work, that is given to us. What is the probability that he took the bus? Can I say similar way we can solve it? Can someone solve? Yes, come on. Is it that
We
tough?
can solve it.
You
Ma'am,
can
we
solve.
can solve it through biased term.
Similar way, I'll just write it like probability that he's late given bus, given his probability of riding in the bus and divided by probability of getting late. So what is the probability that being in bus he's late? Can I say 7%?
Yes, ma'am.
What
Yes, ma'am.
probability of being in bus, riding in the bus?
0.4.
0.2.
Yes, ma'am.
Now what is the probability of getting late? Similar way.
Yes.
Anyone is having the doubt what I'm writing? How I'm
No, ma'am.
calculating probability? Okay. So this probability I'm already having, probability of bus I'm already having, probability of late. Okay, one more thing, probability of late. So basically probability of car I'm already having, probability of walk, and all these probabilities I'm already having. So I'll get the probability of getting late, and therefore I'll get the answer here. Is it fine?
Yes, ma'am.
Now coming to the
Yes, ma'am.
second. I think it's similar only what we have solved. Can someone explain her the second question? Can someone read the second question in the assignment?
Pick two real numbers a comma b infinitely at random from infinite sample space, uniformly at random space, infinite sample space, minus 1 comma 0 and 1 comma 0 comma 1 respectively. What is the probability that a squared plus b squared greater than 1 by 4?
Yes, can someone tell me?
Ma'am, here the radius of circle, ma'am, changes.
What is
Ma'am,
the radius
let's
of the
ma'am.
circle? Can I say 1 by 2?
Yes, ma'am. Yes, ma'am.
So basically only the radius of the circle is changing, and we are only considering the quarter circle. So that is by 1 by 4. So pi by 16 I can say. And then we are saying that what is the probability that it is greater than 1 minus pi by 16. Everything else is same only. Am I correct?
Ma'am, once again repeat, ma'am, please.
Okay. Can someone explain in detail, yes, what you were saying, that how it is changed from that? This was the last one. Is it same or is it different? Yes. Who was speaking? I think Preshit, Arvind, or Sobik. Anyone, any one of you were explaining the last question last time? Yes. Come on.
Like I have to explain the same thing.
It's the same thing only. Okay, what is the difference?
Like
The only
here
difference is radius.
intervals are changed, and like it is last time both of them were -1 and 1, but here A is from -1 to 0 and B is taking positive intervals. So
Area.
for that, and yes, the radius is half this time.
Ma'am, but we are squaring them. That's why, ma'am, the range difference is not, ma'am, to be considered.
We're squaring. I didn't get it.
Area is also same, madam. But we are considering 1/4 of that area.
1 by 4th of the area.
The area, yeah.
Why 1 by
Because
4?
it is a square plus b square is greater than 1 by 4 only, no, ma'am. That's why.
Yes. So 1 by 4. Now
Is it
what
correct,
is that?
ma'am?
Yes, absolutely correct. So that is why we are getting 1 minus pi by 16. Can I say? Because it's outside of that.
Yes, ma'am.
Okay, let's proceed. all of you, like if any of the question is again you are having the doubt, mail me. I'll let you know. Suppose you roll a die twice. What is probability? Sum of two rolls is even, given that first roll was even number. Yes.
It's 1/2 is the answer, ma'am.
Absolutely correct. How?
When you are rolling the die first time to get even number, probability is actually 3/6, that is 1/2. The conditional probability. So probability of getting sum of even numbers in the second row is given. Getting even number in the first row is same as intersection of getting even number, that is probability of A intersection B divided by probability of B. Conditional probability, this one.
Can I say that okay, if
In
in
you're
easy-
rolling the second time, the sum is an even number, ma'am.
yes.
That is actually 9/36.
Okay. That is 1/4.
Divided by 1/2.
So basically,
Ma'am, it is similar to saying getting odd in second dice, given that we have
yes,
gotten odd in first dice.
what I mean to say, you have to solve this intersection and everything. If I know that okay, first one is even, is given to me, and we want that sum is even, then I can say that the second one should be even. Then only I can get the sum as even. Am I correct?
Yes, ma'am.
Yes, ma'am.
Then what is the probability of getting second one even in 6 even?
3/6.
3/6. Can I say simply rather than solving all of this?
Yes, ma'am.
Am I correct? The person who answered?
Yes, ma'am. Yes. Okay.
Yes. So we can save our time by like doing just this thing. Yes, your approach was also fine. Let's go to the next assignment, and the assignment other question is also similar to that, like Preshit was saying. Okay. What is expected value of total number of dots appearing on top face when we roll two normal six-sided dice? Yes, come on.
Ma'am, is it 7.66, ma'am?
What you were answering 7.66. What about others? What others think?
Seven, ma'am.
7. How 7? Yes, it's correct. How 7? What about others? Is it 7? And how 7?
Like we can say if there is like there are two dices here, so
Mm-hmm.
we can say that expectation of now total number of dots on one dice is like 1 plus 2 like all the appearance all the outcomes like 1 2 6 have be is equal to 1 by 6, so expectation is yes 1 plus 2 plus 3 by 4 by 6, that's 3.5. And since we have two dices, so by linearity of expectation the expectation gets added up to get 7.
Absolutely correct. So basically, like we can get 1, 2, 3, 4, 5, 6, and then as by linearity of expectation, they get added up and we get 7. Next question. Can someone read this question? Yes, can someone read this question aloud?
Ma'am, Alai's rule, a magical dice. A die has 2021 sides with faces 1 to 2021. Also suppose that probability face K twins up,
Turns up, turns up, turns up.
turns up. Alpha K, what's that?
It's like read this. Probability of face is equal to k is equal to alpha k. That is what it is written. Also suppose that probability face k turns up, alpha k means face is equal to k is equal to alpha k with the same probability constant alpha. So what they're saying, maybe I'll solve it. So what they're saying, Alice is ruling and it has 2021 sides. So it is given to us that probability of face is equal to k is equal to alpha k. That is what it is given for all k. Now, what is the expected value? If I have to find out the expected value, first of all, I have to find what is alpha. Can I say, I'll write something, then can someone explain me? Is it correct?
Yes, ma'am.
The sum of the
Yes, ma'am.
probabilities will add up to 1. What is this? What is this?
Sum of natural numbers up to 2021.
Yes, absolutely correct. Sum of natural numbers. What is the formula?
Yeah, n into n minus 1 divided by 2, where n is 2021.
Is it
N
n
N
plus
plus
one.
1.
1 by 2? Huh. So can I get the value of alpha?
Yes, ma'am.
Now coming to the expected value. This is alpha k. So basically alpha as a constant will come out, and we have got the value. Suppose from this I'm not solving. Now what is this?
Sum of the squares.
What is the formula?
Ma'am, n plus 1, 2n plus 1 divided by 6.
So can I get here the value of the expected x? Because n I'll put as 2021, and basically and then I'll solve. I'll have the alpha here as well. Can I get expected x from here?
Yes.
Is it fine? Sometimes the question looks very tough, but when we'll solve it, was it easy?
Yes, ma'am.
So sometimes it's like looking like tough only. We have done nothing. Only we have calculated the value of alpha by saying that, okay, the sum is equal to 1, the sum of the probabilities, and then calculated the expected value of them. Next question. I think again the similar
Ma'am,
question.
the previous sum is also similar to this one only now, ma'am.
The previous?
The previous sum, there also we rolled 2 dice.
Yes, yes. We can say that, yes.
Why there you calculated one simple average there?
Here we were not given anything. It's like 2021 sides are here. The question itself is different.
The expected value of x is x into p of x only, no, ma'am.
That is what I have calculated, x into
Here,
p.
ma'am. Previous sum?
Previous one. Can someone tell me why I have done this? If I say that, okay, I am rolling a die, either I can get 1. I'm calculating like, okay.
You're rolling 2 dice.
1 by 6, I'll tell you. 1, what is the probability of getting 1? 1, x into px plus x into px plus x into px plus 4 if I get.
Ma'am, ma'am, sorry to interrupt. Ma'am, you are rolling 2 dice, ma'am.
Yes.
I'm 2 normal sided dice. So outcome is 1, 1, 1, 2, like that only, no, ma'am. You are rolling 2 dice.
Okay, wait a second. What is the expected value of total number of dots appearing on top face when we roll 2 normal 6 dice? Okay, you mean to say it should be pairwise, like 1, 1.
Yeah, pair 1, 1, 1, 2, like that only, no, ma'am. Because we are throwing 2 dice at a time.
What are the others?
It will lead to the same answer.
I'm also thinking if we do 1, 1, 1, 2, and either we'll do like this, it will lead to the same answer only. That is
okay, ma'am. Okay, okay. Thank you. Okay.
We'll try once, otherwise we'll see. Like, I think it will lead to same. Yes, obviously it will lead to same answer only. X is a random variable. That takes values 1 or 2 with equal probability. Y is random variable. I think it's solved in class. That takes value. Something different is there only, I think. Somewhat they have changed between 1 and x plus 1 with equal probability. What is expected value of x plus y? The options are yes, can someone read the question and explain?
X is a random variable that takes values 1 or 2 with equal probability.
Hmm. Hmm.
Y is random variable that takes value between 1 and x plus 1 with equal probability.
Hmm.
What is the expected value of x plus y?
There also we have done linearity of expectation only in the question which he was asking. Here also we can do it. So what will be the expected value of x?
Ma'am, 1 plus 2 by 2.
Hmm. Hmm. Yes, 1 plus 2 by 2 also, or 1 by 2 by 3 by 2 basically. And what will be the expected value of y? Let us take the case when x is equal to 1. X can be 1 or 2. Okay, let us take the case when x is equal to 1. Then what will be the values of y if x is equal to 1?
2.
1 or 2.
2.
1 and 2.
1 and 2. So basically I can say that y can take 1 and 2 here basically. And what is the expected value of y if x is equal to 2?
1, 2,
1,
and
2, 3.
1, 2, and 3. Now can someone tell me what is the expected value of y overall? Can I say probability of x is equal to 1?
2.5. It's
Ma'am,
no,
3.5.
no, sorry.
Have you solved like this only? What is this? Am I correct? Or doing something wrong? Is it correct or something is wrong here?
Ma'am, it should be 1.5.
How?
EY, when x is equal to 1, it should be 3 by 2, I guess.
Yes.
Like the same way we have done calculated for the x.
Okay.
Expectation of x.
Yes, it should be 3 by 2. Okay, and what about this?
Ma'am, 2.
Should be 6 by 3, yes, 2.
Yes, yes, yes. So basically 1 by 2 multiplied by 3 by 2 plus 1 by 2 multiplied by 2. So 3 by 4 plus 1, which is equal to 7 by 4. And what is the probability, what is the expected value of x here? 3 by 2.
Ma'am, 13 by.
Is it like the same answer you got?
Yes.
Moving on to the next question. Maybe this is done. Okay. This is also done. Maybe I'll move to assignment 4 quickly. Try to solve this assignment 4. Okay, this is also done. Okay. Some questions are repeating that I'm not doing. Let x be Poisson random variable with parameter alpha. What is expectation and variance of x respectively? Yes.
Is it alpha comma alpha, ma'am?
Yes, absolutely correct. So basically mean and variance of the Poisson. Basically we'll have the alpha comma alpha here. Okay, let x, y be two independent.
Ma'am, can you solve assignment 3, fifth question, ma'am?
Assignment 3, fifth question. Assignment 3, fifth question. Wait a second. Okay. The Indigo counter airport has two personnel. Let's see. So what they're saying, the Indigo counter has two personnel. Alice enters the counter while two travelers, Bob and Claire, are being served. She's okay. She's next in the line. Assume that the time an Indigo personnel spends serving in a customer has exponential distribution. This is the question you're saying, na? Am I audible? With lambda is equal to 9, what is the probability that Alice is last of the three customers to be done, to be served? Can someone answer? We have already solved in the class though. Yes. Please everyone open the assignment number 3, question number 5. So any idea about exponential distribution? What is
it have memoryless property.
Yes, memoryless property. What does, can you read the question and can you try to answer it?
Ma'am, the Indigo counter at the airport has two personnel. Alice enters the counter while two travelers, Bob and Claire, are being served by two personnel. Ma'am, she is next in line. Assume that the time an Indigo personnel spends serving a customer has the exponential distribution with lambda equal to 9. What is the probability that Alice is the last of three customers to be done being served?
So what do you think? What should be the answer?
Ma'am, the answer should be half.
How?
Ma'am, if one person leaves, ma'am, then Alice, chance comes, ma'am, and after that, ma'am, the probability of both having being served first is same because it follows the memoryless distribution.
Basically,
memoryless property. Sorry.
Memoryless property. So, we can say that what is the probability Alice is of last of the three customers, and we are saying suppose they both are getting service time at, getting served at equal rate. So either Bob will basically served, or Claire will basically end up. So basically whosoever will end up before, what is the probability that they'll basically come up, that is 1/2. Either one of them will basically be done, like either Bob will be done or either Claire will be done. It will not be like how much time they have already spent. It will be like, because it's a memoryless property. Is it fine? Yes.
Yes, ma'am.
Okay. So basically, as it will be not like how much time they have already been served, it's like how much time the remaining service is left, rather than regardless of the time how much they have been served, because we are talking about the memoryless property. And Alice will be start like when both of them are being served. So the service time, whichever will be served first, suppose Bob is finished or Claire is finished, that is 1/2 probability. So Alice is last of the three customers, basically 1/2 probability. Okay, where were we? Next question, the last question of today's class. Yes, what do you think?
Third option.
Third option.
Nice. How?
Its variance of x plus y is variance of x plus variance of y plus 2 times covariance of x comma y if x and y are independent random. If x and y are random variables. If x and y are independent random variables means covariance of x comma y is 0. That's why
Yes.
it is variance of x plus variance of y.
Absolutely correct. Or in other words, can I write like this? Variance of x minus variance of y. I can write it as variance of x plus variance of minus y if they are independent. Basically, covariance is 0. I can say that variance of x is it correct?
Yes, ma'am.
Yes, ma'am.
So if you guys are having any doubt in the further, or if you want that the other assignments to be shared, or please mail me. I'm writing again my mail ID in the chat. All the best for the exams. I hope the classes and the session went well.
Yes.
Thank you so much.
Ma'am,
Thank
what
you.
about week 7 and week 8 assignment, ma'am?
Oh, they are left. Okay, I'll suggest you to solve yourself. And if you're having any doubt, please mail me the question, whichever the doubt you're having. Maybe, because I thought, okay, these questions we haven't seen. Maybe you'll see these questions as well.
Ma'am,
Yes.
ma'am, what will be the format of exam, ma'am? Like
Yeah, I'm
question
unaware of
will
this.
similar to.
I'm unaware of this. Maybe I thought to ask. I forgot that. Okay, you mail me. I'll let you know.
And
So
ma'am,
whatever.
also about ma'am negative marking.
I'll let you know. Mail me once. Remind me because I'm not having your mail ID. So I'll reply.
Okay, ma'am.
Okay.
No negative marking, sir.
Okay.
Okay. Thank you.
Okay.
Okay. Thank you so much, class. I hope the sessions went well.
Thank you. Thanks a lot, madam.
Thank you, ma'am. Thank you, ma'am.
Thank you. Be in touch
Thank you,
with
ma'am.
doubts further. Okay. Thank you.